everybody and welcome to another video. Today this overview might seem like a beginner's lesson or a beginner's introduction to a constructor in C++ and default constructors in C++, but it's really not. And the reason I say this is since this channel is all about breaking down C++ at the very low level, and this video is rather high level compared to the other ones on this channel. But either way, without further ado, let's get straight to it. So what we have here is, let me just clean this up real quick. So this will be N, and I will just do this. So what is the importance of default constructors and direct constructors in C++? The importance of those is absolutely indispensable for your performance at runtime. And here's why. Let's first distinguish the difference, or let's just distinguish the destructors within, or the constructors or initializers within the direct constructor and inside of a function body. So first of all, if we have something like this, and let's say we are not initializing our S and S1 at all, meaning neither in the direct constructor nor the constructor body, we will have the default constructors called on them as well as the default destructors, but they are called at the end of the function or at the end of the object lifetime within the destructor function that we defined here. And if I reveal the linked code behind that, and also if I reveal the linked code here, there's actually one thing that I'd like to point out, and that is you will see the call of the destructor of S2 and S1 here, and you will also see the destructors at the end of the object's lifetime. And you would be wondering why am I calling these guys twice, or these constructors twice, if that's gonna resolve in undefined behavior, if my destructors are not smart enough, or it is more likely that these will result in slower code. And you will see a lot of these in C++, especially when using try and catch, and and sometimes even the compiler will generate them at the O2 level, but these are cleaned up at O1 level if you're not using assert and if you're not using try and catch. And the reason they're called here is because we are using so-called safe assert, where we need to clean up all the previous variables leading up to that point. Anyway, let's get back to our initial discussion. So if I'm initializing my members of a class or a struct within the constructor body, I will be invoking the move, and as you can see to the right, I will be invoking the move constructor, or rather the copy assignment in this case, or move assignment. And not only that, but you will be creating an R value, which will need to be cleaned up at the end of the expression. In other words, at the end of the semicolon. And I have mentioned this on numerous occasions in many of my videos, where R values end where or when that expression lifetime ends. And that is especially the case, and if only the case, for when you're triggering a function such as move assignment or move constructor, because essentially behind the scenes this is just a function, and let's say it is S1 operator move, where I'm picking up this S1 and S1 constructed here. So everything behind the scenes is just a function. However, it is extremely important to note that it is essentially a function behind the scenes. If we reveal the linked code, you can see the operator move assignment, but these are evaluated from right to left, and it's guaranteed that they are evaluated from right to left, because that is the grammar rule in both C and C++, where you have an assignment expression, you will have to evaluate from right to left, and the compiler makes sure to have this function arguments evaluate from right to left, and also make sure to check out the video C++ evaluation order of function arguments if you are not 100% sure why I even bring this up. Anyway, so not only do we trigger or invoke the move assignment, we also invoke the unnecessary constructor in this case, since we are 100% sure that we're moving that value, and also make sure to check out the videos of C++ optimizing move semantics and C++ hacking the structure series in order to understand what I'm getting at here. So there is a lot of redundant stuff that will slow our code at runtime, and in order to avoid this, you would initialize your stuff in the direct constructor of the respected class. That can either be this kind of constructor, but if you have something to pass on to those constructors, you would do something like this, or you would use brackets, curly brackets. Now, what's really interesting about this is the fact that we are not allowed to initialize our members if they're not in order. Why? Here is why that's the case. Let's say I have a size member that is going to be reused, or an attribute member, whichever it is or whatever it is, that is going to be reused within my direct constructor. And let's say I pick up the n. So let's say I want to kill two birds with one stone here. And I want to both assign size and use it to allocate a piece of memory or anything like that. And I will get an error at runtime, and that's why I used fsanitize address. By the way, this option is only available for Linux this or similar kernels and distributions, if I'm not mistaken. I don't think you can do this in Windows. Anyway, that's why this is the case. And even if I move the only way this would work is if I move the size at top of the pointer, and now I will have no errors and memory leaks at runtime, since now the order is correct. But if the order in my end, it's kind of, it can be difficult to provide the right order, because you would want to define your members from largest to smallest, because that way you're giving the compiler the best shot at optimizing the padding of your class, because that is essentially a struct. And that's where the motivation came from C initially, obviously. And needless to say, you would want to have your members defined from largest to smallest. So at the same time, you want to make sure they're in order if you want to pull off something like this. But then just think about it a little bit and say, let's say my size is here. Why would I want to reuse my size here if n and size is the same? So it's all about code refactoring at the end of the day when it comes to these kind of scenarios. So just write better code like that and you will have no problem whatsoever. Now, that is the reason the compiler gives a warning to initialize your member attributes in order if you're using the direct constructor. And that's why I always advise everyone to use the v-error flag, which means we are treating all of our warnings as errors, and now we have nothing to fear in terms of giving this a run after we compile it, since now I won't compile it at all, and I won't link it, and I won't make an executable anyway. And I always make sure to emphasize to always use at least the O1 level optimizations. And the reason for that is it just gives you a better static code analysis if it can be resolved at compile time. One use case is the union members may not be initialized. That's the kind of error we would get from O1 point on. And another kind of error is or are we gonna get that there? 1 second. 0. Yeah, another kind of error we would get at O3 actually, because now we have enhanced our static code analysis, the compiler itself will determine. It's almost like it functions like a constant expression where with primitive types it can figure out my code, and it will say, okay, your array subscript is out of bounds here. You cannot use 0 if you are trying to initialize your value at that memory address. So it will have to be 1. And that is my advice. Always use O3. I would say I know build times in C++ are questionable, and Linus has made himself clear on that as well compared to typical GCC build times. So now if I reorganize or reorder my members to something like this, and I'm also making sure that they are organized or ordered from largest to smallest, I will have no errors. In this case, there are essentially warnings, but in this case there are errors at all, and I'm making sure I'm initializing everything now in order in my direct constructor. And also, what I wanted to make notable in this video is that all of the delete operators in C++, be it this delete with the brackets where I am invoking constructors and cleaning up the memory of the underlining buffer, as well as this built-in operator, delete, they all have already internally implemented a check where we are guaranteed that we are not going to apply any operations if our PTR or our pointer reference is null pointer. So always make sure for in that case. So I definitely don't need this check here in situations where I'm not using PTR in any way, because I'm already doing the internal check in the built-in delete. So I am sort of doubling up work that would happen and take place at runtime, which is ill-advised to have repeating yourself in the code, especially with if statements, because you will get penalized at runtime, because an if statement is a conditional jump, as you already know. So unless you have a pointer, let's say you implemented polymorphism, or you're using a reference counter where you need to first check whether your pointer is null or not, and you would need to do something like this, then if my count hits 0, I'm going to delete my PTR. So that's the kind of case you would need to have pointer not equal to null, or you can have it combined in the logical operator so that you don't repeat yourself twice. But that's really, yeah, that's really a matter of personal choice and preferences. So each time you're doing a null pointer check and you're forced to use something on heap, make sure to verify whether or not you are doing a redundant check of if or not. Okay, that'd be all for this video. I hope you enjoy watching it. and I hope you find it useful in your learning path or your code base. Thank you very much, and thanks for watching.